Hello. This problem is also given by the American Mathematics Competitions 10 Prep Book, Volume 1. The problem goes as follows. The two tangent circles with radii 3 and 1 respectively have an external common tangent as shown. Find the area, or find the shaded area. Okay, so the first thing I'm going to do is I'm going to write in these 3 and 1. The next thing I'm going to do is I'm going to draw some lines so that we can figure out some common things between them and eventually solve this. So I'm going to be drawing a right triangle over here. I'm just going to be labeling some points. Okay. So the first thing to notice is that df is equal to dA minus FA. Now, FA is equal to CB, so that is equal to dA minus CB. Now, the reason I put in these terms is because we know both of these lengths, which is 3 minus 1, so it is equal to 2. dF is equal to 2, making this one equal to 1, which we already knew from the problem. So its usefulness is debatable, but it's a cool proof to make sure that none of your information is wrong. Okay, so the next thing we can do is show that find the length of DC. This might look a little weird at first, but remember these are radiuses, so this length over here is 3, and if you move over that radius over here, this length is 1. So DC is equal to 3 plus 1, which is 4. So I'm just going to go over and label that. Now, right now it's an important thing to notice that DCF is a 30, 60, 90 triangle. Okay. The next thing we're going to look at is is to see how we're going to find the shaded area. You see I've drawn this trapezoid over here, and that area of the shaded region is going to be the area of the trapezoid minus the sectors of both the circles. So we're going to start with the area of a trapezoid. It is equal to these lengths. That's just the a plus b over 2 is just the average side, so it's just like BH, just like a square. So in this case, we will have 4 plus, we need to find the length of AB. Now we can use the Pythagorean theorem to say c squared minus b squared equals a squared, and then take the square root of that. And this is what you get over 2, and now the height is 1, CB is 1, so we don't need to worry about that. And now we need to minus the two circles, so we would have pi 3 squared for this one over 6, because you can tell that one's the 30 and this one's the 6. You can tell this one is 120 degrees because you have to add the 90, and this one, you don't have to. So it would be the 60 degrees, which is 360 divided by 6. So it would be pi r squared, which is 9 pi, and then divided by 6 to make it that many degrees, to make it 60 degrees, and then this is 120 degrees, so it's 30, and then plus this 90. So it's going to be pi 1 squared, or just pi divided by 3, because 360 divided by 3 is 120 degrees. Now, once you simplify this, that's basically your answer, and I've gone ahead and I already know that it's equal to this. So this is the answer. It's a weird solution for a weird shaded area. Thank you for watching, and goodbye.